Mistral seems to be leading the charge with large language models, innovating in the area of making more efficient models smaller that outperform the really big ones. Recently, we've seen that Mistral has sort of given an open source approach to providing fully accessible weights for the entire model that has been trained, which is very exciting because this makes LLMs a lot more accessible to everyone. Now, we don't have to worry so much about licensing and the like. And their latest model is the idea of having a mixture of experts, the Mixtral of experts. From what I can see here, they have essentially done everything the same as their normal 7 billion Mistral parameter model. They've done something a little bit different though. They split up those parameters into 8 distinct sort of paths that they count as experts. The Mixtral 8 by 7 billion. And what's exciting about that is that 8 by 7 billion, so using this new approach, what they have here is Mixtral. It's the same architecture as their Mistral 7 billion, with the difference being that each layer is composed of 8 feed-forward blocks. So that means we have 8 segments, each with their own feed-forward. For every token at each layer, there's a router that sort of selects 2 of the 8 experts and combines their output, sort of maybe like an averaging or the two. So they run it through 2 models essentially inside the same model, and then they merge that result to provide the next round of inputs for the generation process. So each token, or I suppose each input here, has access to 47 billion parameters, but only uses 13 billion of those parameters during each generation cycle. And there's an input token size of 32,000 tokens, which is a lot. That's quite a bit. And it outperforms Llama 2 at 70 billion parameters. So, wow, GPT-5 on all the benchmarks. And it vastly outperforms Llama 2 on mathematics, code generation, and multi-language benchmarks. So we're seeing like a notable amount of reduction in the number of parameters and a significant improvement on its overall performance. The Mixtral LLM model, we're taking a quick look to see what is it doing under the covers. Kind of how does it operate? And they've added sort of a new, I suppose it's novel in a way. At the same time, it actually does a good job. And what they've done here is they've taken the inputs, and a router will select 2 of the 8 models essentially inside of all of these weights, and only 2 of the feed-forward networks are used simultaneously. Each input vector is assigned to 2 of the 8 experts by a router. The layer's output is weighted sum of the outputs of the 2 selected experts. Oh, weighted sum. Okay. So it's basically, okay, so they just add them together. And each expert, which you see here in these blocks, is just the standard feed-forward block and a vanilla transformer architecture. So what I was kind of originally thinking is that the router would be more embedded inside of these experts in the feed-forward model. However, we are seeing that's not the case. They are separate and independent transformer feed-forward models. The result is we're seeing a superior capabilities in math, code generation, tasks, multilingual understanding, and it outperforms Llama 70 billion parameters. And you're able to successfully retrieve information in the 32K tokens regardless of the sequence link and the location of the information. So that's even extra more interesting because that means it can perform better at making sense of kind of what you're after. So you provide it with some context, and you might ask the question, hey, does this document hold any details about XYZ? You might be able to ask questions about a document for there. So they have 2 models, a standard model and then an instruct model, and it looks like one is more along the lines of a chat and the other is more of a completion. They're both Apache 2.0 licensed for free, academic and commercial, so we can profit on these models. This is really powerful. We're reading through the academic paper for Mistral's Mixtral of experts. Taking a look, they do provide us with some good information up front so we understand kind of how overall the model works. So they've got 8 experts in this case, right? So they've got 8 transformers, completely independent models essentially, that will work together in a coordination. The idea is they've got 8 experts here, and 2 of them will be used at a time. When you put input data into a router, it will select 2 of those, and then it will capture the output, sum the results in a weighted fashion. Let's see here, it says weighted sum of the outputs of the expert networks where the weights are given. Oh, so it looks like here it kind of looks like you can say you might want a 3rd expert in there, and then that 3rd expert, I suppose at a certain point, if you like say use all 8 experts, it's going to get a little mushy. So just sort of combining 2 seems to do the trick, performs well. 2 is better than 1 in this case, but they probably tried with 8 and they were like, no, it didn't work. Mistral's benchmark for the Mixtral of experts model seems to perform very well with fewer parameters in these large language models. I'm taking a look here. It might be a little difficult for you to see on the screen. Just taking a look, the yellow bar is the one that we're currently looking at. That's the one that is outperforming the other models. Very interesting. So we've got fewer parameters. Let's see here. With the green bar is the Llama 2 70 billion parameter, and we have much fewer parameters with the Mixtral. They mentioned 47 billion, 8 by 7, which I counted to 56 billion, if I did the math right. Or is it only 7 billion? I need to validate that. It feels like it's 7 billion, but it mentioned up higher that it said 47 billion. Right here, look, access to all 47 billion parameters, but only uses 13 parameters during the inference. Here we go. Here's the answer. Okay. Well, oh, come on. All right. So I get it. So they say it's using 13 billion during inference, though, you know, it's switching between the experts. So you can't say 13, right? You have to say 47 billion or the 56 billion. Either way, that's still less than 70 billion. And it outperforms all these other models. Isn't that satisfying? So it's still more performant. During inference time, it's only using 13 billion of those well, it's switching between the experts, so it's kind of, but for each pass, it's using 13 billion. So technically, like 5 times faster, 6 times faster, more efficient, fewer parameters, higher accuracy, and better outcomes. They are kind of like, I feel like they're cheating a little bit, because if they're saying, you know, 7 billion and then they multiply that too, is kind of like 14 billion. This will be the 14 billion-ish range, but that's per input sequence, right? So it's really a 56 billion parameter model, but you're only using 13 billion of those at a time. So it's kind of like, you know, I just would have preferred, you know, a little more clarity on that in specifics. The good news is, though, it's still performing significantly amount better. Like if you look at the Mistral model with just 7 billion parameters versus the Mixtral model. Oh wait, no, this is Llama 2. All right, so we've got the Llama 2 with this red, the labeling on these charts here. So we've got Llama 2 is this red, and the Mistral is the orange. And then you've got Mistral 7 billion, and then you got Mixtral 8x here. All right, so we see just by adding a mixture of experts, it significantly jumps up. Yeah, I don't know. I feel like it should be closer to over here, because under the hood, it really says it's, you know, 57. It said 40, what is it, 46 billion? I'm reading this properly. 47 billion parameters, but it only uses 13 during inference. So the model is ginormous, though. At inference time, it will perform better because it's using, you know, that fewer amounts, using 1/4 of the parameters in any given pass. So I will have to say, this is an improvement. It is better, faster, stronger, cheaper. And the great news is we can go download it for easy, cheap, free. Just click the download button and you'll have it on your computer. It'll be ready and available for you to use. And it's open source, Apache 2.0 license. Look at all these pretty, okay. We got to take a deeper dive into this to see what's going on. All right, what we're looking at here is the router selection of which model it's choosing. The expert ID, they do have a set of experts here. It does appear that they've trained independently these experts, which is kind of interesting, or at least that's what's I'm guessing, like GitHub, PubMed, abstracts. These all seem like dedicated data sets. Independent, Wikipedia is another. You can see the selected choice of each one. For the first token, kind of always prefers arziv. And then here's a full distribution map of, for each input, the choice. It looks like it's a fairly uniform distribution. Ever so slightly, though, it does pick one or the other, just by a little bit. So it's kind of interesting. Over time, we might potentially see an increased number of experts and a router that makes different choices that vary vastly based on, we might improve like the router logic, right? And make that a little bit different. Like which one of these transformer models that have, you know, billions of parameters is the next token going to pipe into? And here's an example of, it's kind of hard to see here, but you can kind of see like some of the first, like the whites, the spacing here, the indentation on this code appears to be favored by a couple of different. It's like the beginning indentation's always favored by one of the models, by one of the experts. And then also based on syntax, you can see here that there is a color that represents like sort of the first word in that code space. It's usually always favored by one of the experts. It even says it here. All right, selection of experts appears to be more aligned with the syntax rather than domain of expertise. That's very interesting.